This is the tutorial for Chapter 7, Section 4, titled Approximating Square Roots, day number 1. And actually, we're not approximating square roots today. It's the name of the section, but actually what we're doing is classifying real numbers. And so when we classify real numbers, we're looking at two different types of real numbers. Here's a little graph that shows the different types. We've got rational numbers and irrational. And if we look at rational, it has that word ratio in there, see, R-A-T-I-O, and that means we have a fraction. So that's all a ratio is, it's just a fraction. So if we can write it as a fraction, then it's going to end up being a rational number. Irrational, well, IR, that stands for not rational. So not rational means we cannot write it as a comparison of two numbers, cannot write it as a fraction. And so there's a few different types of numbers that you're going to see that way. One of those is pi. Whenever you have pi, well, that's an irrational number. The other ones are going to be roots that are not perfect, like a cubic root that's not perfect is going to end up being an irrational number. A square root that is not perfect is going to be an irrational number. But we could have a square root that is rational, and that might be like the square root of 4. If I took the square root of 4, that would equal 2, and that would be a natural number. A natural number are counting numbers, like 1, 2, 3, 4, 5, 6, and so on. And so a square root of 4 is 2, so that would mean that that's natural. And all natural numbers are also whole numbers. Whole numbers are all those natural numbers, but including 0. And then they're also all integers, because integers are positive numbers and negative numbers. So they're whole numbers and their opposites. And those are all rational numbers, all numbers we can write as a fraction. So you can take 2, which is a natural number, and write that as a fraction as 2 over 1. So the number 2 has lots of different names. We could call it a natural number, a whole number, an integer, and a rational number. So the key about rational ones that are just rational are ones that are fractions, that don't become natural numbers, wholes, or integers. So they're either going to be a terminating decimal, like this one here. This is a terminating. So anytime we've got a terminating decimal, we could end up writing that as a rational number, or a repeating. If it repeats, it's a repeating decimal. And so the number that repeats in this case is the 3, because that vinculum's over the 3. So here's a few examples. Square root of 12. So this is not perfect. So it's not a perfect square. And since it's not a perfect square, that's going to tell me that this is an irrational number. So what this one ends up being. Negative 0.25 repeated. So this is a repeating decimal. Repeating decimal. So that tells us that it's just going to end up being a rational number. It's a number I can make into a fraction, but it's not a whole, it's not a natural, it's not an integer. This one we've got to be careful. Just like the square root of 4 is 2, well, here I could take the square root. It makes negative 3 because of the minus sign out in front. The square root of 9 is 3. So this is two numbers. So this one is an integer, and it is rational. So we have to write both of them. So integer and rational. Now this one here, we can do some division. See, 4 does go into 72. It goes in there 18 times. And so this one is many different numbers. This is a natural number. This is a whole number. This is an integer. And it is a rational number. And so it makes all 4 of those parts. And pi, well, we just talked about before. Numbers that are irrational are numbers that are not perfect squares, or not a cubic root, and we have pi as well. So this is irrational. And so those are the types of problems you're going to see on tonight's homework. Good luck.